Understanding mobile communication technology. For most of us, mobile phones have become an essential part of daily life. But you may have wondered how exactly a phone call is made and why there are different generations of mobile networks. Let's explore the fascinating technology behind mobile communication systems. How mobile phones transmit voice. When you speak into your phone, the microphone captures your voice and converts it into a digital signal. This process is accomplished with the help of a MEMS sensor and an integrated circuit, IC. Your voice is transformed into a series of binary data, combinations of ones and zeros. An antenna inside the phone sends these binary signals out as electromagnetic waves. These waves convey the binary data by modifying certain wave properties, such as amplitude, frequency, and phase. For example, a low frequency might represent a 0, while a high frequency represents a 1. To establish a connection, these electromagnetic waves must reach your friend's phone. However, such waves weaken over distance due to obstacles like buildings, electrical equipment, and environmental conditions. Even without these factors, the curvature of the Earth limits the range of electromagnetic waves. The role of cellular networks. To overcome these limitations, mobile networks use cellular technology. The entire coverage area is divided into small regions called cells, each with its own cell tower and specific frequency band. These towers are typically connected by underground or undersea optical fiber cables to provide both national and international connectivity. When you place a call, the electromagnetic waves from your phone are received by the nearest cell tower, which converts them into high-frequency light pulses. These light pulses travel through the fiber cables to a base transceiver system at the tower's base for further processing. The signal is then directed to the destination tower, which converts the pulses back into electromagnetic waves. Your friend's phone receives the signal and reverses the process, allowing them to hear your voice. While mobile networks involve wireless transmission, much of the communication infrastructure relies on wired systems, such as fiber optics. How calls are routed between towers. A mobile connection is only successful if the signal is properly transferred between your cell tower and the tower near your friend. But how does the system know which tower your friend's phone is connected to? This task is managed by a mobile switching center, MSC. The MSC is a central hub that manages several cell towers within a specific region. When you buy a SIM card, your information is registered with an MSC, known as your home MSC. This MSC keeps track of your service plan, current location, and activity status. If you travel to a new region, the MSC in that area becomes your foreign MSC and communicates with your home MSC to keep your location updated. To ensure the network knows where a subscriber is, the system performs location updates. These updates occur periodically, whenever a phone crosses a certain number of towers or whenever the phone is turned on. Making a phone call, a step-by-step example. Imagine Emma wants to call John. When Emma dials his number, her home MSC receives the call request and forwards it to John's home MSC. If John is still within his home MSC area, the call is sent directly to his current cell tower. The system checks whether John is on another call or if his phone is switched off. If everything is in order, John's phone rings and the call connects. If John is not within his home MSC region, his home MSC forwards the call request to the foreign MSC currently serving him. The foreign MSC follows the same steps to locate John's phone and establish the call. Managing limited frequency spectrum. Efficient use of the frequency spectrum is crucial because there are billions of mobile users, and the available spectrum is limited. Each subscriber is assigned a specific frequency range to transmit their data. There are two key techniques used to manage this limited spectrum. 1. Frequency slot allocation. Different frequency bands are assigned to different cell towers to avoid interference. 2. Multiple access techniques. Within a single frequency slot, multiple users can access the network simultaneously using technologies like time division multiple access, TDMA, or code division multiple access, CDMA. Evolution of mobile network generations. Over the years, mobile communication technology has evolved through several generations, each bringing improvements in speed, quality, and features. 1G, first generation, introduced wireless phones, eliminating the need for landlines. However, it used analog signals, which were prone to interference, resulting in poor call quality and weak security. Additionally, 1G networks inefficiently use the frequency spectrum through frequency division multiple access, FDMA. 2G, second generation, introduced digital communication using TDMA and CDMA, improving call quality and security. It also brought services like SMS and basic internet browsing. 3G, third generation, focused on faster data transfer, allowing speeds of up to 2 megabits per second. This made it possible to use features like GPS, video streaming, and voice calls over the internet. The 3G network marked the transition from basic phones to smartphones. 4G, fourth generation, brought speeds ranging from 20 to 100 megabits per second, enabling high-quality streaming of videos and movies. Technologies like orthogonal frequency division multiple access, OFDMA, and multiple input multiple output, MIMO, were used to achieve these higher speeds. MIMO allows multiple antennas to operate in both phones and cell towers, boosting performance. 5G, fifth generation. The latest generation focuses on enhanced MIMO technology and millimeter wave frequencies. It supports seamless connections for the Internet of Things, IoT, including smart homes and autonomous vehicles. With significantly faster speeds and lower latency, 5G will revolutionize connectivity. Conclusion: mobile communication is a complex system that combines wireless transmission with wired infrastructure to provide seamless connectivity. Through a series of innovations across generations, mobile technology has evolved to support everything from simple phone calls to advanced services like video streaming and smart devices.